Okay, everybody. Good morning. This is Mike Bayer. He will be talking about SQLAlchemy and beyond.
Hello. I have a lot of slides here, and I'm going to try to get through them all, which I understand is a challenge here. They will be on my blog. So, if I go kind of quick through a code example, you can go download it later and look at it. Those of you who have been using SA04, I think you probably know most of what we're going to do here. So we'll start like this. Trip through the past, starting with SQLAlchemy 0.1, released in 2006. And those of you who used it, remember it had a very small API. It was a couple of objects, tables, columns, engines, mappers, and object store commit. And that was pretty much the whole thing. And it was, people kind of liked it, although it was kind of limited. Thread local, everything, everywhere, always. That's how we did it in version 1. We kind of thought, well, I was the only person at the time, so I kind of thought we'd do kind of a SQL object type of thing on top of it, but I didn't want to get into that because I wanted to focus on just one idea. But then people quickly came along with Active Mapper to kind of serve that purpose, as well as SQL Soup was Jonathan Ellis's great little plugin. Then 0.2. Theme of this release was Here Come the Users. We had to change the way we were doing 0.1 very fast because it became apparent that while we had some nice ideas, things were not really going to grow with the user base the way we hoped. So I wanted to change it really fast. So the API that looks more familiar today, like metadata, session, query, connection, and all that decoupled stuff, came out it was kind of somewhat inspired by Hibernate, and it was meant just to give a lot more flexibility to the application approaches people wanted to use. Thread local, everything turned off, but we kind of left it optional. And we wrote it really fast. 0.2, I wrote it in like 3 weeks because, I really wanted to change how people were doing things. I wanted to, once 0.1 was out for a few months, I could see that I wanted to change how it was being done, and I didn't want people writing more 0.1 style applications. And the user base was still pretty small, so I made the choice to have all of the pain right there up front. 0.3, thanks for sticking it out. By the time we were at 0.3, people were calmed down and all the, things had sorted themselves out. 0.3 was mostly a rewrite of a lot of internals of 0.2 because 0.2 was written quickly, so we wanted to clean a lot of stuff up. Refactoring, and we made room for a lot of the new features, which, with more refactoring, came out in 0.4. And, at this point, 0.3 was kind of running smoothly. People were building a lot of stuff with it, and things were okay. But we wanted to be better. SQLAlchemy 0.4. Here come the developers. Suddenly I had, not suddenly, but, people finally were really dedicated to helping and adding new features and modules all on their own, not just little patches here and there. So we were able to really enter into a new phase of development. 0.4 is largely about internal refactorings. And also people started kicking our butt about speed. So, okay, we'll, for the first time ever, start looking at what makes us slow and removing it, and that went fairly well. We made SQL expression constructs better. We had a guy come in and give us all the two-phase and save point transactional features, which, we have for Postgres and MySQL right now, and Oracle, Microsoft SQL Server coming up. And the query object was improved, and I'll be talking about that to a fair degree. This is a graph which is, not terrible. It's based on SVN blame, so it's really not totally accurate, but the idea is lines of code versus release, and you can see that when you use SQLAlchemy today, you're really getting almost nothing from earlier releases. We've rewritten a lot of things, and the really big long line there is when we merged 0.4 to the trunk, so that's kind of a scale of how big a refactoring this is. So highlights of 0.4, here's speed. This is our most egregious speed example where we had execute many running for an insert. 0.3 was doing some unnecessary stuff with the 100,000 sets of bind parameters, and we fixed that to not do that when not needed, so that saved us a good amount of time. Code was simplified. The green lines represent SQLAlchemy 0.3 call counts for some various test cases like eager loading, insert many, which we just saw, inserts, selecting, updates. So you can see SQLAlchemy 0.4 is kind of about half the call count overhead of 0.3. And that wasn't really any kind of amazing thing. It's just 0.3 just, had piled up a lot of stuff from us doing a lot of work with very few developers. So here's some highlights of the SQL expression language, what it looks like today. It's generative. We still have backwards compatibility with 0.3, but these days, if you want to do a select statement, you can just, build one up from the columns, then add some where criterion, add some order by, add some group bys. And it's, we think it's pretty easy to read. If your select statement is bound to an engine, you can just iterate through it, execute method without having to deal with anything special there. We've changed the way that operators work to be more intelligent. This table is a SQLAlchemy table with two columns. One of them is integer. The other one is a string. If we do an expression with the integer column using the addition operator, you'll get rendered as the column plus a bind parameter, which represents the number 3. On the other hand, if you use the string, the same operator will produce the string concatenation operator. If you then are using MySQL, which doesn't always have the concatenation operator available, like here, where we bind the metadata to... am I losing sound here? Hello? Hey. If we bind the table to a MySQL dialect, same expression, you get the concat function. So it's all the little plus sign there is figuring out to do the right thing. Similarly, we've improved SQL functions to work better. We say select from now. It'll do what we've always seen it to do. It'll say select now. If you bind to SQLite, you'll get current timestamp, and you don't have to worry about SQLite not having now available. Now also knows that it is of the date-time type, which in the case of some databases, such as SQLite, is important because we need to convert SQLite's string representation of dates to a Python datetime object. Query API for the ORM. Looks a little like the select API. It's generative. A lot of the old methods from the old days, select by, select one by, select first by, all that's gone. I mean, it's deprecated, but these days we do it like this. Filtering is how you add where criterion. Also, we no longer have the .c attribute required when you use columns off of your classes. You can just use the descriptor straight from our user class here to compare as order by. So that's how querying looks these days. Aliasing. This is a longer example. So let's start with a table here. It's called categories. It's what you call a self-referential table, which means it has a foreign key pointing to itself. This structure is commonly referred to as an adjacency list structure. We have a surrogate ID, primary key, a name column, which is the data we care about, and then subcategory of, which references back to another row in the same categories table. We map it, create a base category class, set up a mapper, which will map all the columns in the categories table to the class. We add two properties, parent category, which means every category object will have a parent category object, and it will also have a subcategories collection. So that's a bidirectional relationship, which in SQLAlchemy, those are self-maintaining. So many to one for parent category, one to many for subcategories. The remote side argument indicates that we should use many to one semantics for parent category. One to many is the default. In 0.3, if you wanted to join from the category table to itself, you had to manually create an alias object. And you see here we're querying for category objects. We're selecting from a join of categories to the alias. We have to get the direction of the join condition correct for the kind of query we're looking for. And then we're looking for a category with a parent of some category. 04, it's much easier. You can just say join to parent category, and you tell it to alias the join. Filter calls that are subsequent to the join will take their criterion and have that criterion be aliased against the alias generated by the join. If the filter was before the join, it would be against the base table. So when we run this, we get a SQL statement like this, which does all the joining and aliasing for you without having to have a separate alias object sticking out. Here's a more intricate example. I'll go quick. This is, we want to look for a path, USA/Illinois/Chicago. Look for category objects with the name Chicago, join to the parent category, and those parents should be named Illinois. Join again to the parent, those should be named USA. Give me all of them. This is the SQL. And that's aliasing. Another thing we have is has and any. These are some really great operators that one of our developers came up with, and these are basically synonyms for the SQL exists keyword, which it generates an exists with a correlated subquery. So here we want to find categories who have parent categories with the name of USA. You get a SQL statement like this, where you can say select star from categories where exists, select a row from categories where a parent has the name of USA, and you can see it's doing the aliasing so that the join works out. So that saves you a lot of trouble. And of course, has worked with non-self-referential relations as well. The opposite of has is any. So we want to find a category who has no subcategories, a leaf node. And you'll just say, so it's basically query for category filter where not subcategory is any. So it has no subcategories. There's, so you get that. We get where not exist any subcategories. So I love that. That's one of my favorite operators. We load one node with the name of Chicago. We want to find categories whose parent category is Chicago. We can just compare using the object itself. We don't have to worry about the foreign key identifier being stuck in there or anything like that. You get a straightforward SQL statement that knows what to do. Same way in the other direction, category who has Chicago as one of its subcategories, and you get that. New ORM configurations. How's the time going? Oh, I'm going really fast. Too fast? Too slow? All right. I was worried this was going to take a long time. ORM configurations. In SQLAlchemy 044, we have just introduced, click, this. For people who do not use Elixir, we love Elixir, and we want people to keep using it, but not everyone uses Elixir. We still have the need for a way for people to have a less verbose declarative style of writing their mappings. Active Mapper has really kind of fallen by the wayside, and additionally kind of redefines how you think about mappings. And we really wanted there to be a layer where you still deal with the regular base SQLAlchemy constructs, schema items, mapper properties. And this just basically is a small extension that lets you just move the columns and the relations and everything else into your class. And it really is a tiny little 90-line module that just kind of rearranges how things are initialized. It does very little. It's very non-intrusive. And you can just give it a table name. And you can also do real data mapping with this because you can pass in an actual table object as well. So really you can still do separate table configuration, then join your classes to the tables using, instead of table name, you'd say table equals some table. And then you can still have all of your mapper options in the class level itself. And I think this, for people who are not using Elixir, might be a really good way to go for the large majority of mappings that you really don't need to have a separate mapper set up somewhere. You just want to have it kind of all at once. So I'm pretty excited about that. Collections API. We've got a developer. His name is Jason Kirtland, and we did a tutorial together on Thursday. And he his audition for being a SQLAlchemy developer was to write this huge collections. No, it's not huge, but it's a really nice collections API, which kind of treats Python collections and user-defined collections much in the way the mapper treats your classes. You can really use any object you'd like that has collection behavior within SQLAlchemy with a pretty easy API. This example shows us having a class called myClass mapped to a table with a relation of a collection of elements attached to it. SQLAlchemy uses a list by default for collections, and here we want to use a set. So we just take Python set type, and we just stick it right in there with the collection class option. But then if we had another kind of collection, which is not any kind of, it's not a list, not a set, not a dict, it's nothing, it's just an object, it's called mySet. It's got whatever wacky capabilities we give it. We can use decorators to tell SQLAlchemy which methods correspond to the methods it needs to know about, like appending, removing, and iterating. So we can just take any object that acts at all like any kind of iterable, appendable object, and you got it. We also have some built-in collections that are handy, like a mapped dictionary. This mapping, again, myClass to element, we're going to have a dictionary where the keys of the dictionary are the element name attribute of the element object. And that you can just pull that right out of our import space. You can also map dictionaries where the keys are actually instances with a few more tricks. Dynamic relations. This is something people were asking for a long time. They have a one-to-many relationship where the many side is enormous. They have like an object with 10,000 child items. They want to be able to SQLAlchemy's default behavior is to load the full list of items in by default. People wanted to be able to just look at slices. We've told people, oh, we'll make a query, just do a query. But now we kind of made it slightly more convenient by adding this dynamic relation where the subcategories relation is now a kind of a sliceable query object. So here, if we had a category object called cat, and we want to iterate through subcategories, but we give it a slice, at the point that we iterate, you get a query that is going to apply the correct limit offset. It will not load the full list, and it'll only load in that list. It will query every time you call it. But what's nice is that the dynamic relation can still be written to. You can still append and remove items from it. Those items are placed in kind of a holding zone where we just record things that were added or removed, and when you flush, they'll come through in the flush. So you can treat it pretty much like a list, with more restrictions, but it's pretty good for when you're dealing with a huge collection of items. Okay, here's the big example. We have some new operators that you can use when you deal with an inheritance configuration, and we're kind of focusing on joins table inheritance. In this case, we're going to use an example that we always use, which is this a base class called employee, a subclass called engineer, and another subclass called manager. And in this case, every class will have a row in the employees table. Every engineer will have an additional row in the engineers table. And every manager will have a row in the managers table. The employees table has a column called type, which kind of gives us a clue as to which subtable to look in for a subclass when we load. Here's a mapping. Employee class, manager, and engineer class. The mapping is not using any kind of optimization. It's just going to do a very basic load. We're not adding any joins or any weird select statements in the mapping. It's just you tell it which column tells you is the discriminator for the polymorphic load, and then you give it each subclass its identity. Pretty straightforward. When we query for all employees, you will get this. You'll get a query. It'll select from the employees table, and then for each row, it will do an additional select to either managers or engineers, which is good for some cases and very inefficient for others. So if you'd like to optimize that at the per query level, you can say with polymorphic and you just give it the wildcard, which is one option you can give it, and you'll get a join among all the tables. And you didn't have to write any joins. You didn't do anything. It just did the right thing. With polymorphic, also can take the individual class or list of classes, so that if you want to query for employees, but you need some of your criterion to use engineers, you just say, well, I'm also doing some criterion using engineer objects, so I'd like to do that. So you can see our filter criterion has the engineer status explicitly used in the example there, which is not part of the employee class, it's part of the engineer class. And you'll get a join. 10 minutes. Speed up. Similar to with polymorphic, of type is another operator which you can use in joins. If we have a company class, collection of employees, we can query for companies where employees of type engineer have a status of EE. That's just a way to do the right joins. Okay. New transactional features. We've got transactional sessions. This is actually something that Hibernate has always done, and we didn't do it at first, but we thought it would be a good way, particularly with the dynamic relations, to be able to query for things and have the flush process happen for you. So basically what auto-flush does is it flushes every time you query, whatever is remaining in the session that has modifications. And transactional means the session will just always be open in a transaction, so it behaves kind of like a regular DB API connection. So here we load a user with ID number 5. We change his name to the string new name, and we can immediately query for that criterion, and it'll come right back because the query flushes the new name back to the database. You get it back, and then at the bottom you can just commit your changes. Auto-flush is usually used with transactional equals true because flushes are happening all the time, sometimes by surprise, unless you're paying attention. Transaction nesting, this is basically a wrapper for a feature that some databases support called save point. If you're in a transaction, you can set a save point, which will kind of give you a little marker that you can roll back to just part of the transaction. So we call this a nested transaction. So here we have a connection, a transaction. We insert a row. We do a nested transaction, which will set a save point. We execute another. We insert another row. We roll back to the save point so that the name equals Jack will not be inserted. We commit, so Ed is inserted. That's a save point. The other transactional capability is two-phase. This is when you have more than one transaction. You'd like them all to commit consistently. You don't want one committing and not the other one. So here we have two transactions with two connections. Execute an insert on both connections. Then we say, trans1 prepare. Are you ready to commit? You're definitely going to commit, right? OK, great. Trans number 2, you're going to commit, right? Yep, I'm going to commit. Great. Now we can commit both. That's two-phase in a nutshell. And if they don't work, then you roll them back. And that also is integrated with the ORM. So there's ways that you can use sessions across multiple databases. And the two-phase stuff will kick in for you automatically, or you can explicitly wire into it. And more. Other features. We now allow you to change the primary key of an instance and flush it, and it will do the right thing, including if you need to use on-update cascade. Databases that support it will work, and databases that don't support it, such as SQLite, we will do the on-update cascade in Python for you, with less efficiency because we need to load in all the rows that match the old primary key. You can assign an arbitrary SQL expression to an attribute, like, user.name equals the name column plus his last name, and it'll, when it flushes the update statement, will inline the SQL clause in the update so that if many concurrent, processes were updating the same row, it would be atomic against that expression. Metadata reflect can load full schemas at once. We've always been able to load. We've always been able to say table autoload equals true. It'll go into the database and find all the columns and give you a table object with all of those columns represented, which you can then map. Metadata reflect will search the schema level tables to find the names of all the tables and then give you table objects for all of them. It's really handy to write a script to just drop a whole database. You can just say reflect all the tables and then drop all the tables in order, since we also know how to drop tables in the order of their dependencies. New dialects. Okay. IBM actually wrote us a DB2, or wrote themselves a DB2 dialect. And we also got new stuff for MaxDB, Sybase, Access, and Formix. We have a little horizontal sharding ORM extension, which means that you can store a single entity in, you can spread rows in a certain table across multiple horizontal clusters. This is kind of a weird feature, but people were asking for it. It's sometimes better to just do it explicitly above the session level, but you can also try our API, which was modeled exactly after how Hibernate does it. We have a connection events API that allows you to do things when connection first connects, like you want to set isolation modes, you want to set some kind of encoding properties that can only be set on a live connection, and that just triggers off within the connection pool. So what's coming up? Migrate is back, and this is actually not coming up, it's now. Yep, Migrate, someone took over the project, updated it for 04, and the code looks great, so you can do schema migrations with SQLAlchemy. Dialects will soon decouple SQL compilers from DB API behaviors. This kind of dovetails in with the Jython talk yesterday, where we want to be able to have our MySQL dialect and compiler work with MySQL DB as well as JDBC as well as ODBC, and we're doing a nice refactor where we'll be able to kind of have the same compilers be used with different kinds of DB APIs, so that you can connect, PyODBC, all kinds of ways to get to the same database through different kinds of architectures. Jython support. We're going to be meeting with Frank later this week and really nail the Jython thing down. Customizable class instrumentation. Philip J. Eby decided to email us on our list, and we're like, wow, it's Philip Eby talking to us. And he wants to, he's working on a framework called Trellis, which is like an MVC kind of event-oriented approach, and he totally has his own class instrumentation idea. So he's like, well, I want to use SQLAlchemy too. So we're like, okay, here's kind of this branch we've worked up for you where you can really configure everything about how SQLAlchemy instruments the class. You can totally remove everything we do and write your own thing, and here's the API so that you can still send the correct events to SA so we know what's going on. And we gave, PJE's got commit access on the branch, and we're looking forward to rolling that into Trunk pretty soon. Trellis is his framework that he's using with Chandler. SQLAlchemy books. Apparently an O'Reilly book has been announced and should be coming out in June, and also Mark Ram and I have been contracted to write a book for quite some time now, and this year we're really going to get around to it. So there should be 2 books. There should be 1 book by June, and there should be a second book sometime. It's very hard to write a book. Don't take on that project lightly. And that's it. And I got through all the slides. I'm amazed.
Yes. Okay. Oh, hello? This is working? Okay, we have 2 minutes for questions. Please shout them, and he will repeat it.
You mean the declarative? All right, the question is, how does the declarative layer work with many-to-many, right? Yeah, you just do regular SQLAlchemy. You make a table object, and we're still doing the mapping thing. It's just more convenient. So you make the table object, and you define it how you want, and you just use it with the secondary argument as usual. That's why I like that layer, because it really is still just regular mappers, just kind of, instead of over here, it's over there. It's really all it is. Yeah. We are thinking about it a lot. If you'd like to get on the developer list and talk about it with us, we can roll back. We do have the ability to roll back object state, but there's a lot of ramifications to doing that, particularly with the nested transaction stuff we have. We'd have to really make it be able to store, pretty much set a save point for the objects. And I was actually thinking that my project for Pycon next week here might be to just kind of work out how that would work. If we did do it, it would be another session maker option, like, object managed state equals, I don't know what it would be called, but it would be kind of a thing you could turn on for people to play with, because we wouldn't want to spring it on people in the middle of 04. But yeah, we're interested in that, because particularly the 2-phase commit, the save point behavior with sessions doesn't make a lot of sense unless you can really have the objects kind of go along with your rolling back. So that seems like the next phase. One more. Hi. You mean the customizable? All right, the question is about the class instrumentation. Does it mean that SQLAlchemy doesn't have to touch the class? The instances. Yes, that is, that is what it means. It means that you define how things happen to your instance. You then send events to us. Yep. Thumbs up.